Okay, so this is the introduction to probability. Some of this will be a review for you, and some will be new topics. An outline for the next section of this class, the next couple weeks, we'll discuss probability distributions, probability and randomness, expected values, population means and population variances, covariances and correlations, sample statistics, independently and identically distributed random variables, the central limit theorem, and the law of large numbers. So, introduction to probability and randomness. Everything in the world, or just about everything in the world, has a random component to it. So if you're walking down the street, for example, the next person you see coming down the sidewalk, their gender is going to be a random variable, because we don't know for certain who's going to be coming down the block. A coin flip, that's a sort of standard example of a random variable. We don't know the outcome of the coin flip if it's a fair coin. A roll of a dice, the number of times your computer crashes per year. So the definition of randomness is something that is not yet known with certainty but is later revealed. Some more definitions. The population. For this course, when we talk about the population, we're going to be talking about the universe of all potential outcomes of a random variable. So this, if we're trying to figure out what's the average height of people at CSU, our population would be the people at CSU, everyone at CSU. Not everyone in this class, not everyone we see outside, but everyone at CSU at a particular time. We could also be, another example might be the incomes of all people in the U.S. So our population there is everyone in the U.S. This is, it's almost impossible usually to sample the entire population. It's almost impossible to know everyone's income in the entire U.S., for example, so that's why we end up drawing samples from our populations, which we'll get to later. Outcomes. The outcome of a random variable is also called an event, is the realization of that random variable. An example of this is a coin flip. The outcome, one outcome is heads, another outcome is tails. Probability, it's the proportion of times that a given outcome occurs or is expected to occur. So for a fair coin, the probability of heads is 50%. Some more definitions. The sample space, the set of all possible outcomes. We denote this as S, which is equal to, inside the brackets, heads or tails. That's the sample space for the outcome of a coin flip. Sample space for dichotomous gender variable would be male versus female. We could also have non-binary, so we could have S equals any positive integer like 0 through whatever infinity. An event is a subset of the sample space. We've already defined this as this is an outcome. So for example, we might write this, the event E is a subset. So here, let me grab this little term here. This means subset. This means the 3 sort of equal sign is defined as tails is a subset of heads of tails. So here we have the sample space is heads and tails, and then our event or outcome is tails. You could have multiple outcomes, so that instead of just one, we could have E1 as a subset of the sample space 0 and 1, or sorry, is a subset of the sample space which is all positive integers, but the outcome or event is just 0 and 1. A really important definition for this course, random variable. We will talk about random variables a lot. It's a quantity whose value depends in some clearly defined way on a set of possible random events, which is defined by a probability distribution. A random variable can take on a set of possible different values, each with an associated probability. So that's the probability distribution. We have discrete random variables, which take on discrete values such as 0, 1, 2, or 3. And we also have continuous random variables, which take on any value within 2 boundaries, i.e. anything between 0 and 1. Quick, kind of interesting question for you. How many values are there between 0 and 1? Note in this course that a capital letter, like capital Y, refers to the random variable, and lowercase y will refer to the outcome. We'll often write y equals little y. So that means the random variable is equal, the outcome of the random variable is denoted little y, and the random variable is denoted with big Y. Okay.